Good morning, students. Am I audible? Good morning. So today we have two classes, right? This is Friday. Uh, so from yesterday, I'm feeling a little bit fever also. So I don't think I'm able to take the whole class or not, but I'll try. Okay. Okay. Wait. Let me start officially. So good morning, students. This is a class of uh, rural water supply and on-site sanitation, professional elective 3. So we are in module 2. We are discussing about um, filter, right? Means water purification, basically. So in the last class, if you remember, in the last class we have discussed about point of entry and point of use uh, approach of water treatment, right? So I believe that you have some idea about that, how to categorize a particular treatment plan, whether it is a point of use or point of entry. So I already told you in the last class that the particular treatment plan or particular treatment process that you are do just before drinking, just before consuming for any purpose, that is called your point of use. That means just before using the particular water, the whatever the treatment you're going to do, that's your point of use. Okay. So for example, your water purification or purification system that you have attached in your home. Okay. 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 So in today's class, we're going to discuss a basic concept about filter. Okay. So we're going to discuss about what is actually a filter do, what is the mechanism of a particular filter, mm, and mainly we'll concentrate on a particular filter that can be used even in the rural areas. Okay. So whenever I say a filter, whenever I say filter in a broad way, a filter can be divided under two heads. First of all, the first one is your gravity filter, and another one is your pressure filter. I think these things also have got this thing little bit about these things about in previous semester. Anyway, so I'm giving you a clear picture about that. So basically, filters is divided under two heads. One is your gravity filter, another one is your pressure filter. Okay. So from the name itself, you can understand that gravity filters in gravity filters the flow of water is due to the gravity. Okay, flow is under gravity, right? And when it comes to pressure filter, the flow water is not due to the gravity force. It is basically due to the external pressure force. That means you have to give additional pressure, external pressure, or you can say not gravity force, it's the additional pressure. And how can you give the additional pressure? By using a sophisticated like a pump. Clear? So if I give you a basic difference between gravity filters and pressure filters, so one difference is between gravity filter and pressure filter is that under gravity filter, flow is under gravity, under pressure filter, and external pressure is required. Okay, and another difference between gravity filter and pressure filter is that in case of gravity filter, flow is always downward. As you all know, gravity act in vertical direction only. Okay, vertical downward direction. So basically, if you're using gravity filter, that means you have to allow water only. That will not allow. Actually, water is going to follow the vertical downward direction only, since it's working in gravity filter, gravity force, right? But in case of pressure filter, it is not the way. It is not the case. So in case of pressure filter, flow can be in any direction. It may be in vertical direction, it may be in inclined direction, it may be in vertical downward direction or horizontal direction. Since you are giving a pressure, external pressure, right? So whatever direction you are using to allow the external pressure, the flow will be in the same direction. So in short, we can say that in case of gravity filter, flow is downward. In case of pressure filter, flow can be in any direction. Another difference between gravity filter and pressure filter is that the gravity filter is open. Open means there is no, it is not closed actually. It is not closed setup. But in case of pressure filter, it is a closed setup because you need to uh, create the pressure. We need to maintain the pressure, right? If you if you're not using closed um, kind of a system, the pressure will not be generated or cannot be maintained, right? That means you can say the pressure filter is closed. But in case of gravity filter, it is open. And the fourth number difference between gravity filter and pressure filter is that from the cost point of view, as I already told you, to create pressure in pressure filter, you need a sophisticated instrument like pump. Okay, that means if you compare with gravity filter and pressure filter, the cost is high in case of pressure filter. In case of gravity filter, the cost is comparatively low. And another one, the gravity filter can be used for small scale treatment. Okay, but pressure filter can be used for small to low or low to small scale treatment. Okay, that means comparatively, if you compare gravity filter and pressure filter, the amount of water can be treated in a particular time is less in case of gravity filter compared to if you compare with pressure filter. Oh, sorry, I'm giving a opposite uh, difference. Okay, sorry for that. In case of gravity filter, you can go for large scale of treatment. Okay, so in case of gravity filter, you can treat a more amount of water, but in case of pressure filter, um, a low to small scale of treatment can be possible. Why? Because since you are using pump only, okay, so there is a cost limit also in case of pressure filter. Okay, since there is a cost limit is there, to maintain the cost, you have to create a small setup for pressure filter. That means if you are using a small setup, concentrating or cost of the filter, you are bound to go for treating a small amount of water. But in case of gravity filter, no need of any sophisticated instrument. You can increase the area of the treatment plant, so you can go for large amount of treatment of water. Okay, that means gravity filter can treat more water compared to pressure filter. Since your setup is large in gravity filter, and in pressure filter setup is small. Okay, but if you use large area for treatment in case of pressure filter, you need large pump. Okay, as you know, pressure is what? Force per area. Okay, you know this thing now. Pressure is what? Pressure is what? Force per area. If you increase the area, that means the pressure will be get low. uh, Pressure will be less, right? And if you reduce the area, pressure will be high. So to maintain a particular high pressure, you have to resist or restrict the area of the filter. That's why the pressure filter is uh, can be treat water a small amount of water, or can be treat a small amount of water. Clear? So this is all about your difference between gravity filter and pressure filter. So I'm going to revise all these things like gravity filter and pressure filter. Gravity filter flow under gravity. Pressure filter flow under external pressure. Gravity filter flow, in case of gravity filter, flow is downward. In case of pressure filter, flow can be in any direction. Gravity filter is open. Pressure filter is closed. Cost is low in case of gravity filter. Cost is high in pressure filter. Next, in case of gravity filter, large scale of treatment can be possible. In case of pressure filter, low to small scale of treatment can be possible. So this, how many? 1, 2, 3, 4, 5. 5 difference I have already mentioned it to you. Okay. So this is all about basics of filter. Okay. Now let's discuss about gravity filter basically. So in case of rural areas, we basically go for gravity filter since it is cost effective, right? It is cost effective and it can treat water. It can treat large amount of water. Fine. So it is desirable to use gravity filter in rural areas. Fine. You all, I think you have already seen gravity filter even in your home, right? Wait a second. So when it comes to gravity filter is also two types. Okay, one is your slow send filter, another one is your rapid send filter. Okay, I think this thing also you have got this got in your last semester anyway. Um, so I told you that there are two type of filter like slow sand filter and gravity sand filter. Sorry, rapid sand filter. Sorry, slow sand and rapid sand. So before discussing about slow sand or gravity sand, let's discuss about the basic mechanism of filter. That means how a gravity filter works in treating water. Okay. So even in the last class also we have discussed some part of that, how a filter work. Okay, so I'm going to share the screen again. Okay, my screen is visible or not? Can you please respond? Is it visible?
Sir.
Okay. Yeah. In the last class, we have discussed about that, how a water filter work, right? So water filter is what? It removes impurity by lowering contamination of water using a fine physical barrier. You just concentrate on this word, okay? Uh, a water filter can treat water by using by using a fine physical barrier, chemical process or biological process. Physical, chemical and biological. Basically, these things, this is a very important term, or you can say this is a basic mechanism of filter. That means using this mechanism, a filter can treat water by using physical barrier, by using a chemical process, or by, you can say, by biological process. Fine. If I say method of filtration, filter use sieving. We're going to discuss about how a particular uh, filter can be used as a sieving apparatus, adsorption, ion exchange, biofilm. Okay, all these things we're going to discuss about that. Fine. Okay, so basically we're going to discuss about slow send filter and rapid send filter. Okay, so before that, let's discuss about the basic physics or basic mechanism of filter. So you all know, no, in a particular filter, what component you need. It's a very not a technical question, but usually you have seen a local filter. So what material you can use in filter? Can anyone tell me? You can also write in chat box. Yeah, suppose if you want to prepare one locally made filter, what do you need? What do you need? Filter देखा कि नहीं तुम लोग ने? Okay, anyway, I'll show you. Okay. Okay, wait. Okay, so a particular filter, if I draw a particular filter, let's try whether I can draw or not. I'm trying. Okay, suppose this is a filter. Okay, this is a main, not actually, this is a container. So to make a basic of a gravity filter, what do you need? You need sand and gravel. Okay, so you need to fill gravel first. So this is suppose your gravel, then sand, and above sand you can fill the water. You can pour water. Okay, suppose water is up to this level. This is water level. This is a water level. Okay, these all are water. Okay, wait. This is water. So basically, this is your gravity filter. Basic, locally available. You can make, even anyone can prepare this. Okay. So at bottom, a particular thickness of gravels can be filled. Above gravel, you can fill sand, and above that, you can pour water. And under gravity, you can allow water to pass through it. So it's actually kind of a gravity filter. Water is allowed to uh, go through due to the gravity. Okay, fine. So basically, if I tell you about mechanism how a particular filter can purify water. Purification means what? If you want to go for purifying water, you need to what? You need to resist, or you need to remove the impurities. You need to remove the uh, disease causing uh, microbes, or disease causing suspended matters, heavy metals from the water. This is a basic idea about filter. Okay. Now main question will arise: how can a particular filter, how can a gravity filter can separate that particular impurities from water? Okay. So there is a two, three, four kind of way, you can say four way can a particular a filter can remove or separate the impurities from water. First one, you can say one mechanism is your sedimentation. Okay, one mechanism is your sedimentation. So let me write here also. First is your sedimentation. Okay, so sedimentation, you know about sedimentation means what? What is the basic idea about sedimentation? In sedimentation deals with what? The uh, settling of heavy matters underwater. Okay, this is actually basically about sedimentation, right? So there is also one treatment process or water treatment. You also know, you have heard this term, right? Sedimentation. So as water stored above the sand, I already have shown you that uh, the diagram that below we need to fill gravel, then above gravel you have to put sand, then above that you can put water. Okay, so as the water stored above the sand, due to gravity, suspended solids may settle down. That means basically when the water is stored above the sand, okay, whatever the heavy metals will be present in water, they directly settle in the top surface of the sand. Simple as that. This is a sedimentation. Fine. So this is one mechanism. Second mechanism is your mechanical straining. Mechanical straining. Second one is your mechanical straining. So basically, what is mechanical straining? It is the removal of impurities due to the limited size of voids in the filter media. Have you got this idea? Mechanical straining basically deals with the voids present in sand. Okay, you all know sand have comparatively less voids. Okay, size of the voids is less compared to gravel. Okay, so when water allow to flow through the sand under gravity, so the impurities which are in larger in size compared to the voids present in sand, they get stuck in the voids. Okay, so that's how you can say the soil sand particle uh, behave like a sieving apparatus. Okay, so we have already mentioned, right, in the that method filters use sieving. Sieving means what? You also heard this term in transportation in soil also, na? That sieving is done to what? To separate two particle depending on the size, right? So even in the filter also, the sand, the sand layer behave as a sieving apparatus. Okay, so if the impurities present in water have a larger size comparatively with the voids present in sand, that particular impurity may stuck in the voids, and they will not allow to go through that particular um, filter and reach gravel. Okay, so this is all about mechanical straining. Basically, you heard know this term. Okay, the third one you can say that electrolyte changes. Electrolyte. Oh, sorry. Electrolyte changes. Okay. So basically, these first two you can consider as a physical process. Okay, the third one you can consider as a chemical process or electrolyte changes. Now, what is mean that how can a particular filter use chemical process or electrolyte change, basically chemical process as a whole, to treat water? So electrolyte changes means what? Basically, each particle, like even the sand particle and some impurities present in water, they contain charges. Some impurities or some sand particle may be charged with positively charged ion or maybe negatively charged ion. Okay, they okay that means that it considered the electrolyte changes. It considered that charges that with positive charge or negative charge present in on the sand, also the impurities. Okay, that means the impurities present in water also they carry some charges, and even sand particles also have some charges. Okay, so if somehow if sand and impurities have opposite charge, तब क्या होगा? If sand particles and the impurities which having a particular charge which are get opposite, opposite attracts, so they may get attracted towards each other. For example, suppose sand particle having carrying positively positive charge, and suppose some impurities present in water carrying a negative charge. So that negatively charged impurities may attracted to the positively charged sand particles, and they get attracted to each other and they stuck together. Okay, that means that's how impurities are registered by flowing down to the gravel or to the downward direction. Okay, they may get attracted towards each other and they will stuck with sand and will not follow the downward direction or further with water. They will not go further with water. Clear? So this is all about your physical and chemical, the basic idea. Okay, I'm giving a very in a very simple language. I'm going to giving an explanation so that you can understand. Okay, so let's discuss the next one. Your biological changes. Biological changes. So what do you mean by biological changes? So mainly I'm giving a add-on information, even though I'm going to discuss in the coming classes. Basically, these biological changes, this uh, approach mainly we can see in slow sand filter. Okay, others, the rest, that is 1 2 3, this can be seen. You can see in your mainly physical one. Mainly you can see in your rapid that one, rapid sand filter. But the slow sand filter can treat water basically based on these biological changes. Okay. So what do you mean by these biological changes? How can a filter can use a biologically, how can a slow cell filter or a gravity filter can treat water biologically? So basically, you can first again you could imagine the basic diagram of the filter, that is at downward layer is your first layer is your gravel, that is at the bottom layer is gravel. Then above gravel you can put your sand, and after that you can put your water, right? I'm going to show you again. Okay, so this is your gravel, this is your sand. Okay, and suppose this is a water level. Okay, this is your water. Okay, biological changes means what? uh I already told you now that if you use a finer sand here, if you use fine sand here, the voids will be very less, of course, and because of that most of the impurity will be stuck in the top layer, like that. I will give you a different color for impurities. Say black color, I'm giving a black color. Okay, something like that. Impurity will be stuck in the top surface of the sand. Okay, fine. And they, with due course of time, with due course of time, this impurity which are in the top surface, they form, or they form a film, or they form a layer of impurities here. They form a layer of impurities. Fine. And this impurity somehow they can also uh, or this impurity or this layer is actually known as what? This is known as biofilm. Okay, or biological film. Okay, this particular layer is known as biological film, and this can be utilized to um, to kill the bacteria and virus. Okay, how can this biological film can be used to kill this bacteria and the virus? We're going to discuss now. So basically, the impurity present in water, if I give the water, the impurity can be present in water. So it may be contain organic matter. Okay, the very small organic matter can be present. Then nitrogen, phosphorus, iron, manganese, etc. They can be present as an impurity, and they will stuck in the top layer. Fine, and they make a biological film. Okay, actually it is a layer of impurities. Okay, it is a layer of impurities, and basically it is known as biological film. Okay, the that particular organic matter that present as an impurity. Okay, this organic matter present in this biological film can be used by the bacteria and the virus. Okay, can be consumed by the bacteria and virus. Basically, they are known as heterotrophs. Okay, you can also search in Google what is heterotrophs present in water. They are known as heterotrophs. Heterotrophs like bacteria and virus, they are heterotrophs present in water. So the organic matter present in water or present as an impurity, they can be consumed by this bacteria and virus for their living. Okay, and finally they release, or you can say they simply slowly oxidize the organic matter. The bacteria and virus consume the organic matter and they oxidized. Okay, and finally they release carbon dioxide, acid, alcohol, like that. Fine. And that particular carbon dioxide that that is coming from that oxidation of organic matter by bacteria and virus, that particular carbon dioxide can be used by some autotrophs, okay, present in the impurities layer. Autotrophs means what? You also seen some greeny colored grasses, okay, greeny colored living things nearby the surface of the filter, right? So they are basically autotrophs. Autotrophs like, for example, algae, plankton, they are living things. Actually, what is why they are called autotrophs? The basic idea about autotrophs what? Autotrophs are the microbes. Okay. Autotrophs are the microbes that use sunlight for photosynthesis. And they consume nitrogen and phosphorus and finally produce oxygen. Okay. So I'm again repeating. So organic matter present in water, they are first consumed by the bacteria and virus. Okay. And that particular bacteria and virus mainly actually they are heterotrophs. Fine. I'm giving the name here also. Heterotrophs. Okay. You can also search in Google and my spelling name may be little spelling में थोड़ा गड़बड़ी हो सकता है फिर anyway it's kind of a heterotrophs. Okay. So that like example of heterotrophs like bacteria and virus. Okay. They consume organic matter. Okay. They slowly oxidize the organic matter and produce carbon dioxide, acid and alcohol. Create. And that particular carbon dioxide are used by algae and plankton. Okay. This carbon dioxide can be used by the plant. Okay. That's your autotrophs mainly. I'm giving auto again. Autotrophs. Okay. Okay. Sorry. Please check the spelling also. Okay. I don't think whatever it is autotrophs. Okay. So autotrophs like algae, plant. I'm giving example here. Like here heterotrophs like bacteria, virus. Okay. Then autotrophs like uh, algae, algae like plankton, like that. Okay. They are autotrophs. So it is your heterotrophs. Autotrophs. So this virus and bacteria oxidized the organic matter present in water and they produce what? They produce carbon dioxide. Okay, they produce carbon dioxide, produce CO2. Okay, and that particular carbon dioxide can be used by these autotrophs. Okay, these autotrophs mainly use carbon dioxide for photosynthesis. Okay, this carbon dioxide may be used by these autotrophs present in impurities layer. So we are talking about a particular biological film only. Even in the biological field, the process is going on. Okay, these autotrophs are the microbes that use sunlight for photosynthesis, and they consume nitrogen and phosphorus also, which are also impurities. Okay, and they finally produce oxygen, and they produce these autotrophs. Finally, they produce. Okay, wait, and they finally produce uh, oxygen. Okay. And what is the advantage of production of oxygen? This oxygen is required for the oxidation of organic matter, which is used by heterotrophs. That means this oxygen basically, this oxygen can be used by these heterotrophs. This oxygen can be used by these heterotrophs for oxidation. You know, na? Even in for oxidation, you need oxygen, right? So this oxygen produced by these autotrophs again is used by these heterotrophs um, for uh, for oxidation of organic matter. Okay, so this kind of a it's behave like a cycle. This kind of biological cycle always going on in the biological film present in this particular filter. Okay, so these heterotrophs, that means bacteria and virus, oxidize the organic matter and produce carbon dioxide, and this carbon dioxide used by these autotrophs, that is algae and plankton, and they produce oxygen, and this oxygen again used by these autotrophs for oxidation of bacteria, oxidation of organic matter. Okay, and and this process will go on continuing. Okay, continue in this, by this process finally we can say the whole impurity, not whole actually, more than maximum impurity can be removed from the water. Have you got the idea? So yeah, so this is all about the basic idea about filter, how a particular filter work. Okay, in next class we're going to discuss about slow sand filter and rapid sand filter, and basically we're going to discuss about the difference between slow sand and rapid sand filter. Till then, we're going to start the next class within a very short time. Okay, so till then, do you have any doubt? Have you got the idea about how a filter work? Is it clear or not? Okay, I'll do one thing. First of all, let me stop my recording. Then I will take your attendance. Then uh, we'll take some time of break. After that, we can join again. Okay. So let me stop my recording here.